लैपटॉप पे क्यों? मैं थोड़ा मस्ती किया था ना उस टाइम। क्या? वाह वाह वाह, देखते रहो भाई, देखते रहो, देखते रहो। तो कहाँ तक हुआ है भाई, टॉपिक बताओ। मैंने कराया था आपको मोस्ट सेफ स्पीड एंड बैंकिंग एंगल। स्पीड लिमिट नहीं कराई मैंने। मोस्ट सेफ स्पीड से कम स्पीड एंड ज्यादा स्पीड के लिए स्पीड्स विच आर लेस देन मोस्ट सेफ स्पीड और ग्रेटर देन मोस्ट safe speed. We have two different cases. One is minimum and another one is maximum. Have you done these two formulae? This one and this one. Yes or no? बोलो भाई। Am I audible?
Yes, sir.
No. Have you done these two formulae? This one?
सर हो गया है वो कोनिकल पेंडुलम का टाइम पीरियड भी निकाले हैं।
अच्छा, कोनिकल पेंडुलम भी हो गया। ओके।
Yes.
बस टाइम पीरियड निकाले सर।
टाइम पीरियड निकालना है। ओके ओके, so I will start from टाइम पीरियड, या पहले मैं इसमें दोनों फॉर्मूले ऐड कर दूं, है ना। फोर स्पीड्स फोर स्पीड्स लेस देन most safe speed, which means v is less than root of rg tan theta. In that case, we have the case of minimum possible speed, v minimum, which is equals to square root of rg into tan theta minus mu s divided by 1 plus mu s tan theta. Okay. And for speeds greater than most safe speed, that is, if speed is greater than root of rg tan theta, in that case we have v maximum possible permissible speed, which is square root of rg into tan theta plus mu s divided by 1 minus mu s tan theta. Okay. Now we can start time period of a simple pendulum. Time period of a, sorry, it's not simple, it's conical. Time period of a conical pendulum. Okay. So conical pendulum is defined, yes or no?
यस सर।
This is the arrangement, and there is a conical pendulum at any instant of time somewhere here, and it's moving on a circular path like this. This is the length or the height, sorry, its height from the center of the circle. Let's say this point is center of the circle. So from FBD, free body diagram, we can clearly say that at any instant of time when conical pendulum is having a circular motion, in that case, at any instant of time, mass of the conical pendulum will be working downward, mg, and there will be a tension in the string T, and when you will take its component, let's say angle made by the string from the vertical direction is theta. So this will become alternate interior angle, because this line and this line is parallel. So the string will be transversal and this angle will be equals to this angle. So we can component tension T. So this will become T cos theta and this will become T sin theta. Are you getting it? Are you getting it? Yes or no?
Yes, sir.
Okay. Now let's say length of the string is L. If length of the string is L, if length of the string is L, and you will take the component of L, this will become L cos theta using trigonometry, and this will become L sin theta. Okay. So from figure, the information extracted is first mg is working downward. Second, T cos theta is working upward against mg. Third, T sin theta is working towards center. Since T sin theta is working towards center, it means this will work as centripetal force. Yes or no? Centripetal force. And another information is about radius. From figure, radius of the circular track will be L sin theta. So this is the information we have from figure. Okay. Now we will try to find out everything possible we can. So first relation is that T sin theta is centripetal force. So it will be working as mv square by r or mr omega square. Because in this case we are interested in time period and frequency. So I will select the formula mr omega square. That will be helpful for me. And another relation is T cos theta will balance mg. Okay. So if you will divide them, let's say this is first, this is second. So divide first by second. Divide first by second. So you will get T sin theta by T cos theta is equals to mr omega square by m into g. Tension T will cancel out. Sin theta by cos theta will be tan theta. M will cancel out. R omega square by G. Are you getting it?
Yes,
Are
sir.
you okay? Now we can find out omega square, which will be G tan theta upon R. Okay. So omega square can also be given by G sin theta divided by R cos theta. If you will split tan theta into sin by cos, In that case, you will get the relation G sin theta by R cos theta. And we already know the value of R. R is L sin theta. So omega square will be G by R. R is L sin theta cos theta. In numerator, it is G sin theta. So you can notice that sin theta will cancel out. So omega square is G by L cos theta. And finally, you will have omega, which is square root of G by L cos theta. And omega is given by 2 pi f root of G by L cos theta. If you are interested in frequency f, it will be 1 by 2 pi square root of G by L cos theta. If you are interested in time period is reciprocal of frequency. So if you will take its reciprocal, it will become 2 pi square root of L cos theta by G. So this is the required information. If you are interested in frequency, you can use this formula. If you are interested in time period, you can use this formula. And for the angular velocity or angular frequency, sometimes omega is also known as angular frequency. So we will use square root of G by L cos theta. Interesting point in this formula is that we do not have the factor of mass, which means in conical pendulum, mass of bob, that is the metallic ball which is attached with the string, doesn't play any role. So if you have a metallic ball of 1 kg or you have a metallic ball of 0.5 kg with the same length L of the string, and both the conical pendulum are at the same angle, or the metallic ball with the string is at the same angle in both the cases, then their angular frequency, time period and frequency will be exactly same, because G is constant. So doesn't matter what is the mass in the system. Again, another important point is you can also find out tension T. Okay, you can also find out tension T by substituting the value of sine theta or cos theta into the equation. We can find out tension T. If you will look at omega, omega is equals to root of G by L cos theta. So from this formula, we can clearly see that omega is directly proportional to G, which means greater the acceleration due to gravity, greater will be angular frequency. Greater will be angular frequency means greater is the frequency, because omega is 2 pi f. So angular frequency is directly related with frequency. Omega is directly related with f. So greater the angular frequency, greater will be the frequency of the conical pendulum, which means at those places on the earth surface where gravitational G is maximum possible, frequency will be greater. Frequency will be greater means conical pendulum will oscillate more frequently. So if you will take a conical pendulum at the poles, or you take it in polar region, G is maximum. So there the frequency will be greater, which means conical pendulum will oscillate more frequently, which will affect time also. If you will look at time factor, time is inversely related with G. Inversely related with G, or you can also look at T and F. T and F are inversely related. So if frequency is increasing, time period will decrease, which simply implies that time at polar region and time at equator on that surface will be different, which means time is relative. At different places, time will work differently. Are you getting my point?
Yes, sir.
Another factor which is related with omega is L. So if you will look at L, omega is inversely related with square root L, which means if you will increase the length of the string, omega will decrease, which means frequency will decrease. Frequency will decrease, it means time period will increase. And time period will increase, it means it will take more time for the conical pendulum to complete one cycle. So that is the effect of L factor on the frequency, time period, and omega. Another factor which is present in omega is cos theta. And if you will look at the relation of omega and cos theta, it is again inversely related. Omega is inversely related with cos theta. Omega is inversely related with cos theta. And in this case, from figure, could you tell me what are the possible values for theta? Theta may be from 0 to 90 degree, not greater than 90. That will not be the case of conical pendulum. In fact, I would say theta will be in between 0 and 90 degree. So if you are in first quadrant, if you are taking the value of angle theta between 0 to 90, what do you think? Cos is increasing function or decreasing function? In 0 to 90, cos is increasing or decreasing? 0 to 90 degree, cos is increasing or decreasing? Cos is decreasing function. In interval 0 to 90, cos is decreasing, which means if you will increase the input in cos, output will decrease, which means greater value of theta will give smaller value of cos, and smaller value of cos will give greater value of omega, which again implies that frequency will increase, time period will decrease. Are you getting it?
Yes, sir.
Any doubt?
No, sir.
क्वेश्चंस कराइए टॉपिक से रिलेटेड. बोलो.
हाँ, सर.
क्वेश्चन कराए कि कराने हैं ये टॉपिक से रिलेटेड?
सर क्वेश्चन कराने.
ठीक है. ओके. क्वेश्चन नंबर 1. If length of the string of a conical pendulum is 4 meter and it is inclined at an angle of 60 degree with vertical direction. Find number 1 omega, number 2 frequency, number 3 time period. Okay, this is the question. How will you solve it? Solution. First of all, write down the data given in the question. So we have length of the string which is given to us L, which is 4 meter. And we have the angle with inclination theta, which is 60 degree. We have to find out omega. So what is the formula for omega? Omega is square root of G divided by L cos theta. Let me take the value of G 10 meter per second square. Okay. So what is omega? Omega will be square root of G, which is 10, divided by length of the string, which is 4, into cos 60. Substituted the data. So this will become 10 divided by 4 into cos 60. What is the value of cos 60? Yes, value of cos 60?
1/2.
1 by 2. So 2 to the 4. So this will become square root of 10 by 2, which means omega is square root 5. Then second part, frequency. Omega is 2 pi f, which is root 5. So frequency is root 5 by 2 pi. And everything is in SI system. So its unit will be Hz. Then third part we have time period T, which is 1 by frequency. So its reciprocal will be 2 pi by root 5 and unit will be second. Understood or any doubt?
Yes, sir.
Yes, sir.
Okay. Next question is, in the above question, if mass of the bulb is 0.5 kg, mass of the bulb is 0.5 kg, find the radius, find the, let me write it as, find first part, radius of the circular path taken by the bulb. Second, you have to find the tension in the string. Okay. So if you will in the above question, data is given to us, which is L is 4 meter, theta is 60 degree. L is 4 meter, theta is 60 degree. The value of G is taken 10 meter per second square, and mass of the bob is 0.5 kg. And we are interested in R and tension T. So if you will look at the derivation, we have a relation of R, which is L sine theta. Okay. So radius of R of the circular track will be R equals to L sine theta, which will be equals to what is L? 4 into sine theta is 60. So this will become 4 into sine 60 is root 3 by 2. 2 2 ja 4. So radius of the string is 2 root 3. Sorry, radius of the conical pendulum. Meter. And then we have to find out tension T in the string. So again we have a formula. If you will look at it, T cos theta m into G and T sin theta m r omega square. So you can find out tension T using any formula. You can find tension T using T sin theta equals to m r omega square or T cos theta equals to mg. Which one you will select? First or second? Which one is easy to simplify? Yes, tell me which one is easy? Which equation is easy to deal with?
Second, sir.
Second equation is more easy to deal. So we will take second equation. T cos theta is m into G. So T into cos 60 is equals to mass 0.5 into G 10. T into cos 60 is 1 by 2. 0.5 into 10, which will become 5. So tension T will become 2 into 5, which is 10. What is the SI unit of tension T? Yes, SI unit of tension T. Tension T is a type of force. So its SI unit will be the unit of force, which is Newton. So tension will be in Newton. Understood or any doubt?
No, sir.
आगे चलें. आगे चलें.
Yes, sir.
Okay. Let's take one more question. Question number 3. In the above question, data is same. In the above question, find the kinetic energy of the system. Okay. So what is the formula of kinetic energy? Half mv square. But we do not have v. We have half constant. Mass is also there, but we do not have linear speed v. So what will be its linear speed v? We have to find out v. So there is a connection between v and omega. There is a relation between linear velocity and angular velocity. Could anyone tell me what is the relation? What is the relation between v and omega? Yes, anyone? V is given by R omega. So kinetic energy will become 1 by 2 m. V square means R omega square. So kinetic energy will become 1 by 2 m. R square omega square. Substitute the data. 1 by 2. Mass of the bob is 0.5. Radius R is calculated 2 root 3. So 2 root 3 to the whole square. Omega is also calculated. Omega is also calculated root 5. So this will become root 5 to the whole square. And now you can simplify it. This is 1 by 2 into 0.5 into square of 2 root 3 will be 12 into square of square root 5 will be 5. So this will become 2 6 is 12. So kinetic energy is 0.5 into 6. 0.5 into 6 is 3. Multiply 5. So this will become 15. What is the SI unit of kinetic energy? फोर्स की न्यूटन रहती है, तो काइनेटिक एनर्जी भी न्यूटन होगा. कोई बताएगा एसआई यूनिट ऑफ काइनेटिक एनर्जी? कैसा फिजिक्स पढ़ रहे हो आप लोग अगर आपको एसआई यूनिट ही नहीं मालूम है?
मीटर स्क्वायर पर सेकंड स्क्वायर.
मीटर स्क्वायर पर सेकंड स्क्वायर. हे भगवान उठा ले यार. काइनेटिक एनर्जी, इट्स एनर्जी. व्हाट इज द यूनिट ऑफ एनर्जी?
जूल सर.
जूल. थैंक यू सर, बहुत बहुत धन्यवाद. आपने डूबने से बचा लिया मुझे, मैं डूबने ही वाला था बस. डन. तो इसमें जितना वैरायटी हो सकता है क्वेश्चन का सब कुछ करा दिया मैंने. ध्यान से देखो, इस डेरिवेशन में जितने फैक्टर है सब सिखा दिया. टेंशन सिखा दिया, लेंथ देता है, रेडियस निकालना सिखा दिया. इसके बाद ओमेगा फ्रीक्वेंसी टाइम पीरियड बता दिया. इसके बाद आर एंड टी का क्वेश्चन हो गया. काइनेटिक एनर्जी हमने निकालनी सीख ली. कोई और डाउट है यहाँ तो बताएं. कोई और डाउट है क्या?
नो सर.
ओके. Now let's discuss two questions given in the textbook. Example number 1.4, which is a very long example, so I'm not going to write it. You can look at the screen. ये नजर आ रहा है क्या आप लोगों को? Example 1.4. Example 1.4. A merry-go-round usually consists of a central vertical pillar. At the top of it, there are horizontal rods which can rotate about vertical axis. At the end of this horizontal rod, there is a vertical rod fitted like an elbow joint. फिगर में दिखा रखा है. At the lower end of each vertical rod, there is a horse on which the rider can sit. As the merry-go-round is set into rotation, these vertical rods move away from the axle by making some angle with the vertical. The figure above shows vertical section of a merry-go-round in which the initially vertical rods are inclined with the vertical at 37 degree during rotation. Calculate the frequency of revolution of the merry-go-round. क्वेश्चन समझा क्या? क्वेश्चन है कि मैरी गो राउंड का एक सिस्टम है, रफली बना के दिखा देता हूं. ऐसा रहेगा ये इनिशियली. यहाँ हॉर्स है जिसपे कोई बंदा बैठ सकता है, ओके। एंड जब ये रोटेट करना स्टार्ट होगा, इन दैट केस देयर विल बी अ सेंट्रीफ्यूगल फोर्स. Listen, I'm not saying centripetal. I'm saying there will be a centrifugal force on the vertical fitted rod or on the horse. So they will go in outward direction like this, and there will be some angle theta. So angle theta is given to us in the question when the merry-go-round is in motion. Remember, if merry-go-round is not in motion, in that case, vertical rod will make 90 degree with horizontal rod. If you will look in the figure, this angle will be 90 degree. But if it is in rotation, this angle will change. Okay, it will be some new angle, theta. And theta is given to us. Other information is in diagram. And what you have to do is you have to find out the frequency of the revolution. So क्वेश्चन हम ऐसे परफॉर्म करेंगे, ध्यान से देखेंगे. पहले तो भाई ये बताओ आप लोगों को क्वेश्चन ये समझा कि नहीं समझा, क्या हुआ यहाँ?
समझा सर.
Yes, sir.
ऐसा अरेंजमेंट है एंड दिस इज वर्टिकल रोड. ओके, एंड इसके साथ यहाँ कनेक्टेड है हॉरिजॉन्टल रोड. ऐसे कनेक्टेड है हॉरिजॉन्टल रोड. Okay, and then we have a vertical road like this. Okay, so when it will rotate, it will make a circular path like this. Here is the horse. This is 2.1. This is 1.5. And this angle, when it is in rotation, this angle is theta. So you have to find out frequency. Okay. First of all, what is the formula of frequency? If you will look at frequency, frequency F will be
Inverse of time period sir.
frequency F will be 1 by 2 pi root of G by L cos theta. But it is not conical pendulum na, so we have to make another conditions. दूसरे कंडीशंस हमें बनाने पड़ेंगे यहाँ फ्रीक्वेंसी एफ निकालने के लिए. ओके, सो let's consider this case. This will be the mass of the system working downward mg. If tension in the string is T, so this will become T cos theta because this angle is theta. And this will become T sin theta. Are you getting it? Are you getting it? Yes or no?
Yes, sir.
Yes sir.
Okay. Now this will be the center of this circular motion. This will become radius r, and if this length is 1.5, this will become 1.5 cos theta, and this will become 1.5 sin theta. This will become 1.5 sin theta. Are you getting it? Yes or no?
Yes, sir.
Yes.
So the value of r will be this length, this length, this length is 2.1 plus this length. This length is 1.5 sin theta, and theta is given to us. Theta is given to us sin 37 degree. Okay, sin 37 degree, and the value of sin 37 is there. So sin 37 we can have 0.6. So radius will become 2.1 plus 1.5 multiply 0.6. Okay, if you will simplify it, this will become 2.1 plus 1.5 into 6, 15 into 6. 15 into 6, 90, and there will be point after 2 digits. So finally this will become 3 meter. 2.1 plus 0.9 will give 3 meter. Yes or no? Yes or no?
Yes, sir.
Okay. Now we will, from FBD, we can say that T sin theta will be working as centripetal force mr omega square. T cos theta will balance m into g. And if you will divide them, T factor will cancel out, M factor will cancel out. So we will have tan theta, which is r omega square by g. So omega square will be g tan theta by r. Yes or no? And omega will become square root of g tan theta by r. Omega is 2 pi f. So 2 pi f, omega is 2 pi f equals to square root of g tan theta by r. We are interested in frequency. So this will become 1 by 2 pi g tan theta by r. Substitute the value. F equals to 1 by 2 pi square root of g is 10. Tan theta means tan 37 divided by r. R is already there. That is how much? Yes. R is 3 na?
1.5.
R. R I have calculated na. This
Meter, sir.
complete radius 3. And in question we are given with G, which is pi square. So in place of G we can have pi square, which means you can write it as 1 by 2 square root of pi square into tan 37 divided by pi square into 3. This pi is taken in the square root. So pi square will cancel out. So frequency is 1 by 2 into square root of 10 37. What will be the value of 1037? Anyone? You can use
0.6.
you can use trigonometry. This is 37. Sine 37 is 0.6 divided by 1. So this will become 2 3 ja 2 5 ja 3 5. So this will become 4. So tan theta is 3 by 4. Tan theta is 3 by 4 into 3. 3 will cancel out. So 1 by 2 multiply. Square root of 1 by 4 is 1 by 2. So finally answer is 1 by 4. Understood or any doubt? Yes, any doubt in it?
No, sir.
No, sir.
Okay. ए भाई, ए फर्जी, लग जाओ. Next example is 1.5, which is semi-vertical angle of the conical section of a funnel is 37 degree. There is a small ball kept inside the funnel. On rotating the funnel, the maximum speed that the ball can have in order to remain in the funnel is 2 meter per second. Calculate the inner radius of the brim of the funnel. Is there any limit upon the frequency of rotation? How much is it? Is it lower or upper limit? Give a logical reasoning. Use G equals to 10 meter per second square, and sine 37 is 0.6, which is 3 by 5. So the question is, we have a funnel and there is a ball in the funnel. If you will rotate the funnel, the ball will slide in upward direction, and at some moment it will come out of the funnel. So question is, if you want to keep the ball inside the funnel for always, in that case, the speed of the funnel with which we are going to rotate is will be corresponding to 2 meter per second. Okay, so we are interested in the inner radius of the brim of the funnel, and angle is given to us 37 degree. कैसे करेंगे क्वेश्चन? ये अच्छा क्वेश्चन है. फिगर दिखा रखा है आप लोगों को, ध्यान से देखेंगे. Okay, and if you will look at the angle, it is semi vertical angle, not complete vertical angle, which means in the conical arrangement, this is the conical arrangement. Okay, so semi vertical angle means this angle is 37, not complete angle. This angle is theta. Okay, so at any instant of time, let's say ball is somewhere here. Okay, at this point, what will be the forces in the system? So mg will be working downward. Normal force from the surface will be in this direction, and you can have component of normal force like this. If this angle is theta, this will be theta. Okay, गलत हो गया भाई, ये देखो जरा. If this is theta, this is 90, this will become 90 minus theta, and this complete angle is 90 because it's normal reaction, so this will become theta. Okay, हटा दूं ना मैं? एंगल समझा कैसे निकाला? So this angle is theta, and if you will component it, this will become n cos theta, and this will become n sin theta. So n sin theta will balance mg, and n cos theta will be working at centripetal force, because this will be the circular path, and n cos theta is working towards the center. So n sin theta is equals to mg, and n cos theta is equals to centripetal force, which is mv square by r. If you will divide them, it will become tan theta equals to will cancel out, so it will become rg divided by v square. Yes or no? rg divided by v square. So if you will find out r, because according to the question, if you will look at the question, we are interested in the radius. Okay, so what will be the radius? You will find out radius from here. It will become v square tan theta divided by g. Okay, and maximum possible, if you will look at g will be constant in this situation, and theta is already there 37 degrees, so tan theta is also constant, which means radius is connected with speed v. So whether radius is increasing or decreasing, that will be connected with the velocity of the ball. Okay, it means, listen carefully, it means whatever will be the speed of ball, according to that speed, the ball will select a circular path by itself. तो ये जो फनल है, ये जो फनल है, इस फनल में बॉल कैन ऑल्सो रिवॉल्व हियर, but it will have here speed v1. If you will increase speed, it will slide up, it will go somewhere here with speed v2. If you will give it more speed, it will again go up like this. Okay, so the greater speed you will do, higher it will go, and greater will be the radius. Are you getting it? आर यू गेटिंग इट? इमेजिन कर पा रहे हैं आप? फनल के अंदर एक बॉल, उसे रोटेट करेंगे, तो जैसे जैसे आप रोटेशन बढ़ाओगे, ऐसे ऐसे ये स्लाइड करता जाएगा, एंड सर्कुलर पाथ का रेडियस बढ़ता जाएगा यहाँ. आर यू गेटिंग इट? यस और नो? So we can say that R maximum is connected with V. There is nothing to do with tan theta and G. They are constant values. Okay. So if you want to find out the maximum possible radius, which will be allowed for the ball to be in the funnel, then you have to take its maximum possible speed. And that speed is given to us. If you will read the question, it is written here, on rotating the funnel, the maximum speed that the ball can have in order to remain in the funnel is 2 meters per second. So V maximum is given to us, that is 2 meters per second. Now we can find out the maximum radius of the brim. That is the question na. Calculate the inner radius of the brim of the funnel. So it will become 2 into 2 into tan 37. अभी निकाला पिछले क्वेश्चन में. tan 37 is 3/4 divided by g. Value of g लिख के दिया, 10 पकड़ लो. So this will cancel out. So maximum radius is 0.3 meter, which means, ध्यान से देखेंगे, इसने कहा कि अगर आप मैक्सिमम 2 मीटर पर सेकंड देते हैं तो बॉल फनल के अंदर ही घूमेगा, बाहर नहीं जाएगा. बट ये मैक्सिमम पॉसिबल है, इससे ज्यादा हुआ तो बाहर जाएगा. इसका मतलब ये कहां घूम रहा होगा? बिल्कुल टॉप पे घूम रहा होगा, बिल्कुल टॉप पे, बाहर नहीं जाएगा, बिल्कुल टॉप पे घूम रहा है. और बिल्कुल टॉप पर घूमने का मतलब है ये ठीक ब्रिम पे होगा यहां. ओके, तो ये रेडियस ही ब्रिम का रेडियस बनेगा फिर ऑब्वियसली. तो रेडियस बीम का कितना आ गया? 0.3 मीटर। है ना इंटरेस्टिंग क्वेश्चन, मस्त क्वेश्चन है एकदम। फिर और भी इसने कुछ कहा हमें निकालने के लिए। क्या कहा? इसने कहा कि रेडियस तो आपने बता दिया, अब आप ये बताओ, सेकंड स्टेटमेंट पढ़ रहा हूं, इज देयर एनी लिमिट अपॉन द फ्रीक्वेंसी ऑफ रोटेशन? क्या मैं इसे किसी भी फ्रीक्वेंसी से रोटेट करूं? और आई हैव टू बी केयरफुल कि कितने रोटेशन एक सेकंड में से देने हैं कि बॉल बाहर ना गिरे। क्या लगता है, इफ आई विल इंक्रीज द नंबर ऑफ रोटेशन, ये बाहर जाएगा कि रुका रहेगा? वो हमें देखना है कि क्या होगा इस केस में। अब तक तो हमने ये देखा कि बॉल अगर बाहर ना जाए तो टॉप पर घूमने के लिए मैक्सिमम स्पीड इसने बता दी थी, तो रेडियस क्या रही होगी? दैट इज 0.3। आर यू गेटिंग इट ऑनलाइन स्टूडेंट्स?
Yes, sir.
ओके, नाउ द क्वेश्चन इज कि फ्रीक्वेंसी का क्या कनेक्शन है यहाँ? ओके, फ्रीक्वेंसी का क्या कनेक्शन है? सो वी हैव v इक्वल्स टू r ओमेगा and omega is 2 pi f, so this will become 2 pi r into f, 2 pi r into f। यहां से देखेंगे हम, यहां से अगर v टेंडिंग टू 0 हो, मतलब हम इसे घुमाए ही ना, ठीक है, v अगर टेंडिंग टू 0 है तो v और r के रिलेशन से यहां से मैं बोल सकता हूं r विल बी टेंडिंग टू 0। यस और नो?
Yes.
और अगर r 0 है तो f कहां भागेगा? इन्फिनिटी की साइड? नहीं नहीं, गलत बोल रहा हूं यार, मैं गलत बोल रहा हूं मैं। v टेंडिंग टू 0 मींस r इज टेंडिंग टू 0। हाँ, दैट इज ट्रू। इफ v इज 0 इट मींस बॉल इज एट रेस्ट, घूमेगी ही नहीं, सर्कुलर पाथ बनेगा ही नहीं। तो रेडियस 0 मींस पॉइंट सर्कल आप बोल सकते हो अगर बोलना चाहो तो, बट इसने कुछ और तो लिखा है, मैं ये समझने की कोशिश कर रहा हूँ ये कर क्या रहा है। ऐसे देखो, इफ यू विल लुक एट इट, frequency f is equals to v by 2 pi r, yes or no? frequency f is v by 2 pi r। अब आप ध्यान से देखो, अगर आपने फ्रीक्वेंसी को ये देखना है कि मिनिमम मिनिमम किस फ्रीक्वेंसी से घुमाऊं कि बॉल जो है अप टू द ब्रिम घूमे, बाहर ना गिरे, मिनिमम। क्योंकि आप ऐसा सोचो इसे, अगर आप एक सफिशिएंट फ्रीक्वेंसी प्रोवाइड नहीं करा पाए तो बॉल अपना सर्कुलर पाथ पूरा नहीं करेगा। समझ रहे तुम मैं क्या बोलना चाह रहा हूं? ये कुछ ऐसा है जैसा ऐसा समझो आप इसे, जैसे एक स्ट्रिंग में स्टोन बांध दिया और उसे हम घुमाने की कोशिश कर रहे सर्कुलर पाथ में, तो आप नोटिस करेंगे उस एग्जांपल में इट हैज टू बी रोटेटेड विद सम फ्रीक्वेंसी मिनिमम पॉसिबल। तेज तो कितना भी घुमा दो सर्कुलर पाथ मेंटेन रहेगा, बट धीरे धीरे अगर घुमाओगे तो सर्कुलर पाथ मेंटेन रहेगा क्या? नहीं रहेगा। तो हर एक स्टोन के लिए एंड अकॉर्डिंग टू द लेंथ ऑफ द स्ट्रिंग it has to be some specific frequency which will decide the circular motion। अगर आप वो मिनिमम फ्रीक्वेंसी मेंटेन नहीं कर पाए तो सर्कुलर मोशन बनेगा ही नहीं। तो इस पोर्शन में भी ये यही समझाने की कोशिश कर रहा है कि मैक्सिमम की कोई लिमिट नहीं है, ज्यादा आप कितनी भी तेज घुमाओ कोई मसला नहीं, बट एक मिनिमम फ्रीक्वेंसी है जो होनी जरूरी है। अगर उससे मिनिमम फ्रीक्वेंसी पर आप घुमाओगे तो सर्कुलर पाथ कंप्लीट नहीं बनेगा। तो बॉल का बिहेवियर कैसा होगा, देखो मैं समझाता कैसा बिहेवियर होगा। लेट से यहां से चलाइए, यहां से चलाइए सर्कुलर मोशन करने के लिए, और ये यहां तक गया इधर तक, और प्रोवाइडेड जो फ्रीक्वेंसी है वो मिनिमम से कम है, तो ये इधर तक जा ही नहीं पाएगा इस एंड तक, बीच में ही कहीं गिर जाएगा नीचे। समझ में आ रही क्या बात? आप इमेजिन कर पा रहे कैसे होगा ये? अगर मैं हल्का सा झटका दे के छोड़ दूं तो गारंटी थोड़ा नहीं कि पूरा लेगा वो, हो सकता है कुछ सरफेस तक जाए टच होते हुए एंड देन नीचे स्लाइड हो जाए। समझ में आ रही बात मैं क्या बोल रहा हूँ? ऑनलाइन वालों आपको समझ रहा है क्या?
Yes, sir.
तो इस केस में इसने कहा है कि वी कैन नॉट कमेंट ऑन अपर लिमिट ऑफ फ्रीक्वेंसी। अपर लिमिट ऑफ फ्रीक्वेंसी पर कोई बाउंडेशन नहीं है, नो बाउंडेशन, नो बाउंडेशन। लेकिन लोअर लिमिट डिसाइड करना जरूरी है, अदरवाइज इट विल नॉट बी पॉसिबल फॉर द बॉल टू कंप्लीट द सर्कुलर पाथ। सो लोअर लिमिट का डिसीजन लेंगे हम कि मिनिमम कितनी देनी चाहिए। अब ध्यान से सुनो, एफ इज v अपॉन 2 पाई r। एफ को मिनिमम करना है तो आर को क्या करना पड़ेगा बोलो? मैक्सिमम। आर को मैक्सिमम करना पड़ेगा ना, इनवर्स है। और आर मैक्सिमम कब होता है? जब वी मैक्सिमम होता है। मींस एफ मिनिमम इज वी मैक्सिमम बाय 2 पाई r मैक्सिमम। ओके, वी कितना है मैक्सिमम? 2 अपॉन 2 इंटू पाई। आर मैक्सिमम कितना आया था? 2 से 2 गया। सो मिनिमम पॉसिबल फ्रीक्वेंसी आपको देनी पड़ेगी 0.3 पाई, अप्रोक्सीमेट 1 रिवोल्यूशन पर सेकेंड। ठीक है, अगर आप इससे कम फ्रीक्वेंसी रखो, ठीक है, स्पीड बॉल को उतनी दे रहे, बट फ्रीक्वेंसी अगर कम हुई इससे तो बॉल सर्कुलर पाथ पूरा नहीं करेगी और वो ब्रिम पर फिर रोटेट नहीं कर पाएगी। ये कंडीशन समझा क्या? कुछ नोट करना है इसमें से? बोलो भाई, कोई डाउट है क्या?
No, sir.
कुछ नोट करना है यहाँ?
नहीं, sir.
आगे चले। नेक्स्ट टॉपिक इज vertical circular motion. So there are two types of circular motion. First one is If the circular motion is in horizontal plane, we call it horizontal circular motion. And till now, all the circular motions which you have studied in this chapter were horizontal circular motion. Now there are some cases of vertical circular motion. So vertical circular motion is a circular motion in which the object will be moving on a circular path, and that circular path will present, or that circular path will be in the vertical plane. So will be in the vertical plane. You can imagine it in this way. Let's say floor is the horizontal plane, and then any one of the wall of the room is vertical plane. So if there is an object which is moving in the plane of wall, or in simple words, which is moving on the wall on circular path, that motion will be vertical circular motion. Are you getting it?
Yes, sir.
Okay, two types of vertical circular motions are observed. First one, controlled vertical circular motion, such as a giant wheel or similar games. In this case, the speed is either kept constant or not totally controlled by the gravity. This is first case of the vertical circular motion, in which we are saying that in this circular motion, the speed, either the speed will be constant at all instant of time, at all position, which means that the speed is not controlled by gravity totally. Which means we have some external mechanism to maintain the speed uh, in this case. Another possible condition is that the vertical circular motion is taking place under the influence of gravity. In that case, the speed of the object which is moving in vertical circular motion will be different at different instant of time, at different point on the circular path. Are you getting it?
Yes, sir.
Okay, the second type of vertical circular motion is B, which is vertical circular motion controlled only by gravity. In this case, we initially supply the necessary energy at the lowest point in most of the cases. Then onwards, the entire kinetics, means entire journey of the system or the ball, is governed by the gravitational force. During the motion, there is interconversion of kinetic energy and potential energy. So in case of vertical circular motion, kinetic energy is converted into gravitational potential energy. Okay. So topic is vertical circular motion. First of all, let's define vertical circular motion. Could you define it? Vertical circular motion is a circular motion which is taking place in a vertical plane. In a vertical plane. Examples: uh, giant wheel, or rotation of a stone in vertical plane. Okay, this is circular motion, vertical circular motion. Vertical circular motion is categorized in two categories. Vertical circular motion. Okay, there are two category of vertical circular motion which is given below. First is the category in which speed of the circular motion is kept constant. Or speed is not totally controlled by gravity. In the second case, speed is not constant at any instant of time, and this is possible because in this case speed is not only speed, complete kinetics. Governed by gravity. Okay, and another important point in this case is, in this case, because we are saying kinetic energy is constant, sorry, we are saying speed is constant. So if speed is constant, this implies that kinetic energy will be constant. In this case, we are saying speed is not constant, which means kinetic energy is not constant. So there will be variation in kinetic energy, and that variation is given as kinetic energy will be converted into potential energy, and potential energy will be converted into kinetic energy. That may also take place in the first case, but in first case we are careful. At any point whenever there will be some loss of kinetic energy, we will provide that much kinetic energy at that point with the help of some external agency. That may be an engine or some other technique. Are you getting it?
Yes, sir.
चले भाई, आगे चले। कुछ बच्चे सो रहे थे, उनके लिए वापस से रिकैप कर दे रहा हूं एक बार। We are going to discuss vertical circular motion. Vertical circular motion is a circular motion which is taking place in a vertical plane. So if this is horizontal plane, the circular motion should be in this plane. Like, yes, झूले वाला, like something is rotating here. So that will be vertical circular motion. Examples are giant wheel or rotation of a stone in the vertical plane. Vertical circular motion is categorized in two categories. And the first category is in which speed of the particle or speed of the object in vertical circular motion is kept constant. Uh, Basically, it is not possible for any object to keep its speed constant in vertical circular motion. So if we are saying that speed is to be constant, it means you have to supply some external agency to that object. So either speed is constant or speed is not totally controlled by the gravity. Because if speed will be controlled by gravity only, it will not be constant at each position or at any instant of time. So first case is the case in which we will use some external mechanism or technique to keep the speed of the object constant in vertical circular motion at any instant of time at any position on the circular track. Because we are saying speed is constant, it means kinetic energy in the first case of the system will be constant. Again, this kinetic energy will be constant because we are using some external agency. So if at any instant and at any position in the circular path, kinetic energy is decreased by some amount, same amount of kinetic energy will be provided by the external agency, whatever be the external agency. In case of giant wheel, it is an engine which keep rotating it with constant speed. Second case or second category of the vertical circular motion is in which speed is not constant. And in simple words, we are saying that this type of vertical circular motion uh, is governed by the gravitational force, which means in this type of vertical circular motion, we will provide some amount of energy at the initial state of the journey. And once we have provided that amount of energy, we will not provide it energy further. In that case, energy of the object will be changing. Kinetic energy will be converting into potential energy and potential energy will be converting into kinetic energy. If I take an ideal case means I consider that air resistance is not present. So if air resistance is not present and you keep or sorry you start word नहीं मिल रहा यार you give this system initial amount of energy in such a way that it will complete one cycle. And I am saying that there is no resistance. Air resistance is zero. It means once it is in vertical motion, then it will always be in vertical motion by itself. बस एक बार आपने एनर्जी प्रोवाइड करना है इनिशियल स्टेज में. Once it is done, then it will keep moving in vertical motion by itself. This will be possible if and only if there is no resistive forces present in the environment or in the system. If there is air resistance, in that case, the provided energy will be decreasing definitely because of air resistance. And in that case, I cannot guarantee whether the object will keep on vertical circular motion. In this case, what will happen is that it will have vertical circular motion for some time, and then after some time its energy will be reduced and the vertical circular motion will be collapsed. Okay, ये खत्म हो जाएगा फिर उस केस में. So these are two different category of vertical circular motion. समझ में आ गई बात या कोई डाउट है यहाँ? बोलो. ये कंप्लीट डिस्कशन पकड़ में आया कि कोई डाउट है?
समझा सर.
Okay. Now the second topic or the second concept in vertical circular motion, we have point mass undergoing vertical circular motion under gravity. Means we are considering the second case. What we are saying is that we do not have any external energy which will provide us energy at any instant of time whenever we need that amount of energy, but we will give the system or we will give this point mass initially some amount of energy, and According to that amount of energy, we will try to decide whether this point mass will complete its journey of vertical circular motion or not. Okay? Yes or no? Okay. So let's try to understand it. Next concept which we are going to discuss is point mass undergoing vertical circular motion under the gravity. Okay. So arrangement is we have a mass, point mass, like a metallic ball, small metallic ball, and this point mass is tied to a string or rope. We will consider the string to be massless. There is no mass in the string. So complete mass in the system will be mass of the metallic ball or the point mass you are taking. String is inextensible. Inextensible means string do not contract or stretch by itself, or it will not stretch or contract in this case. Flexible. Flexible means it is flexible string, which means it can change its direction easily. Okay. And then this system means metallic ball and string. Metallic ball and string. Then this metallic ball is set in vertical circular motion with the help of string. Okay. So let us consider a bob of point mass M. Point mass M attached to a string. Attached to a string which is massless, comma, inextensible, massless, comma, inextensible, and flexible. Okay, as given in figure. And figure is given to us. नजर आ रही क्या? इस सर्कल बनाने का नहीं है यार, इसमें बहुत प्रॉब्लम होती है. ओके, this is the center of the circular path, vertical circular motion, and we have different instant of time at which the bob or the ball will be at different position. First position is the lowermost position. We are calling it B. Second one is the uppermost position A. Lowermost position is B. Then we have a position here which is C, and another position here which is D. Okay. So we will try to find out velocity and tension in the string at these different positions A, B, C, and D. These four positions are standard position. So most of the questions are framed on these positions. No. Out of these four, two are very important or of wide use, lowermost and the uppermost case, which means cases at position A and the case at position B. Okay. At any position of the bob or the ball, there will be two forces which will be working constantly on the ball. First is weight of the ball, mg downward, which will be constant. It will not depend on the position because weight is m into g. Mass is independent of position. In this case, g is also independent of position because circular track is not very big. Circular track or the circular path is not that much big that gravity at point A and gravity at point will be different. So we can say that g is constant everywhere. In this case, m is constant everywhere. At any position A, B, C, and D, mass will be same. So weight will be exactly same at all positions. So whatever will be the mass at point A, same will be B, C, and D. So weight is mg, and it will be working downward at any instant of time and position. Second force is tension in the string, which is provided by the person who is trying to rotate the ball in vertical circular motion. That is force due to tension or the simply tension in the string. Okay. About tension, remember tension in the string in vertical circular motion will not be same at all instant. Will not be same at position A, B, C, and D. So tension in the string will be different for different location, which means tension at point A will be different than tension at point B and C and D. Are you getting it? So let's try to write down the forces involved in this system. कौन कौन से फोर्सेस प्रेजेंट है? फर्स्ट वन वेट mg डाउनवर्ड, ग्रेविटेशनल फोर्स बोल सकते हैं हम इसे. वेट mg इज ग्रेविटेशनल फोर्स. सेकेंड फोर्स इज टेंशन इन द स्ट्रिंग. And in this case, tension is not constant. So tension in the string. Tension is not constant, which means tension at point A is not same as tension at point is not same as tension at point C and is not same as tension at point B. Okay. If we supply some amount of kinetic energy to the ball at this point, let's say I provide this ball speed v at point B. So I am going to write it at Vb. So Vb is the speed provided by some external agency to the ball at point B. Provided Speed indicates that we are providing some amount of kinetic energy to the system. So at point B, there will be some kinetic energy, half mv square. And as you will go from point B to point D, motion will be in this direction. Yes or no? And velocity at point D will be same as velocity at point B, or it will be different? Yes? Same or different? Different. So velocity at point B is different, velocity at point D is different. And if you will look in the figure, you will understand, if you are going from B to D point, if you are going from B to D point, in this journey, will the speed increase or decrease? Motion is in vertical plane, remember, and you are going from this to this, means you are going at some height. So speed will decrease or increase? Decrease. Yes, it means in the track B to D, speed will decrease. There will be retardation. And if you will go from D to point A, or decrease hogi, further there will be retardation. So I can say that if you are going from B to D and D to A, in this journey, speed decreases. Speed decreases means acceleration A will be working in opposite direction of the speed, which means it is a case of retardation. Retardation, okay? Now you are at point A, and when this ball will come from point A to point C, will its speed increase or decrease? Increase. So A to C speed will increase, and C to B, again it will increase. In this case, again speed is not constant, speed is increasing. And in this case, because speed is increasing, we will say acceleration is in favor of speed, which means it will be accelerated. Acceleration. Are you getting it? So this is the journey of an object in vertical circular motion, which is governed by gravitational force only. When the object will go from lowermost point to topmost point, its speed will be decreasing continuously. It means it will have minimum possible speed at point A, which means in case of vertical circular motion, listen carefully. In case of vertical circular motion, minimum possible speed will be at point A, and maximum possible speed will be at point B. Okay? It means to keep an object in vertical circular motion, if you are providing it some speed at the lowermost point, you have to give more effort, because at that point you have to provide more speed to it. On the other hand, if you are starting the journey from the topmost point, you will have to give less effort, because at that point we have to provide minimum possible speed to make the object have vertical circular motion. Are you getting it? Okay. If you will take any position in between these points, anywhere, let's say this is the position, what will be the FBD of the ball? So mass will be working downward like this, and tension in the spring will be towards center T. If you will take its component, one component will be in this direction, mg cos alpha, and another component will be in this direction, mg sin alpha. Okay? So if you will look at tension T and mg cos alpha, we can say that both these forces are working against each other, which means net force towards the center will be T minus mg cos alpha. One more important point is mg cos alpha cannot be greater than tension T. If mg cos alpha is greater than tension T, circular motion is not possible. Because for any object to be in circular motion, you will need a centripetal force. And centripetal force always work towards center. So if I say tension T is not greater than mg cos alpha, which means I am saying centripetal force is not enough. Yes or no? So in that case, circular motion is not possible. So it is guaranteed that in this case, tension in the string should be greater than mg cos alpha. Are you getting it? Or any doubt? Yes? Okay. At point D, gravity will be downward and centripetal force will be towards the center, which will be given by tension at point D. This will be tension at point anything. Let's say this is point E. This will be TE. Okay. At the topmost point, this will be tension at point A, and in the same direction you will have mg. Because mg is also working downward, and tension in the string will always be towards the center. The same is true in the case of C. It will be tension and this will become mg. Are you getting or any doubt? Are you getting or any doubt?
Getting, sir.
ओके बाकी का अगले लेक्चर में करेंगे क्योंकि पूरा डेरिवेशन है ये. भाई ये नोट्स वगैरह लगेंगे क्या आप लोगों को? पीडीएफ भेजू कहाँ बट? ग्रुप में हूं मैं ग्रुप में ही नहीं हूँ. मैसेज करो मुझे जरा. एनी डाउट?
No, sir.
ओके ये सेंड करता मैं. हाँ भाई मैसेज किया क्या? वाओ इतने फेमस आदमी का नंबर नहीं है तेरे पास. बेइज्जती कर दे रहे हो. 9997483001 है ना फ्यूचरिस्टिक नंबर 3001. अभी तो 2025 ही चल रहा है. जल्दी करो. आज तो डांस होगा शायद, डांस होगा आज तो, बनेंगे ना वो। हाँ भाई, किया क्या मैसेज? नाम नहीं आ रहा। लो भाई, लोगों सेंड कर दिया, एंजॉय करो। कर दूं डिलीट? सॉरी, डिलीट कह रहा हूँ, एंड कर दूं मीटिंग? ऑनलाइन वाले बच्चे तो चले गए पहले।